we are continuing the migration to Synapse Analytics, and we're going to be looking at the ability to repartition the data on the fly. To do that, we're going to be using just one table here now to show us what we need here, and this is dt small 10m. We're going to be creating some new partitions on the fly. So you can see by default, we're using distribution replicate. It's according to the best practices. If a table is under a certain size, then we have to use the replicate, otherwise we use hash. And to select the, sorry, where is it? To select the correct distribution for your use case, you are free to override anything that we have. And while I overrode the distribution from replicate to hash, I have also used the partition specification. So we are partitioning over dt column for specific values, basically by year. While we used a single partition to start with, we ended up with 5 partitions here. For this specific thing, we have our own parser. So if I just type something here, I can see, yeah, we have invalid syntax. I can also get rid of those and, for example, now use 4 partitions instead of 5. It's all the same, right? Now, if you go to the output here, you can see, instead of the distribution replicate, we are now also using hash, and we are also specifying the partitions. However, specifying the partitions is not enough. You also have to load the data and create the tables and create the staging tables in a very, very specific way to make this efficient. However, actually, that's what Omni Loader does for you. So if you now go and load the tables, we're connecting to the source and target databases, and we are creating the staging tables for you. We are now going to start loading data into those staging tables. By partition, you can see that we have already started in partition 1, then 2, then 3, and now 4. We ended up with 4 partitions. And we did this in the recommended way, according to the best practices. So we're waiting for the data to be ingested, and then we'll take a look at the SQL used to make it happen. So the way to do it optimally is to create the table in such a way that it has all partitions in place, and then create all of the staging tables, load all of the staging tables, and then switch partitions in place, and then getting rid and of the staging table and dropping it. We do this without ever blocking anything, right? So as soon as a certain staging table is done, we are going to be firing up the job to switch partition, and it's already done. So we have ingested 10 million records in 4 partitions in data load was under a minute, right? So let's open logs here. And if you go and take a look at the statements, you can see, all right, so we have dropped the table that we have been creating in the past demo. We have created the staging table, all of the staging tables actually. And if you scroll down, you can see, okay, so we are loading data into the staging table and firing up all of these loading jobs. And then we are switching partitions into the target table and getting rid of the staging one. In the end, we are creating index here. And that's all there is. And you can see the process is exactly the same as if you would be copying one single simple table from one local database to another. We are now loading it and repartitioning on the fly without any additional complexity.